On a cold December evening in 2009, my son Colin and I were on the way to McLean Hospital. We arrived at Boston Logan Airport and it was late. We stepped through the frozen mesh and into a taxi headed for McLean, one of the finest psychiatric hospitals in the world. Boston's weather bore no resemblance to the mild Louisiana winters so familiar to us. We had entered another world now, far from home. Physically and figuratively. The temperature made our bodies shiver, prickling our skin, and the circumstances around our journey quickened our hearts. After a silent cab ride, we arrived at the steps of McLean Hospital, where I stand today. Colin, the fiery athlete with a Cheshire Cat grin and the dark blonde curls, had said, "Mom, I'm in trouble. I need help." And this is where we came for help. Colin was diagnosed with bipolar disorder during his life-threatening psychotic episode. This revelation forever changed, reshaped, and rerouted his world and ours. Even though he endured immense suffering, it was a time of hope because he had a good prognosis and a path forward. However, as time passed, Colin had extensive treatment and a conveyor belt of hospitalizations. The reality of his unresponsive illness revealed itself. His difficult prognosis crystallized. Then, as in too many families, Colin was not the only member with bipolar disorder. 3 years later, my other son, Austin, fell similarly ill. For 4 years, Colin endured daily visions and voices. He had not a moment's peace, and he ended his life in 2014. 9 months later, after a parallel journey with unresponsive psychosis and extensive treatment, Austin died of the same terrible illness. Today, I've returned to McLean to visit the Harvard Brain Tissue Resource Center located here. The brains of those affected with psychotic illness and the close relatives are desperately needed to find the cause of bipolar disorder, schizophrenia, and other brain illnesses. For many complex reasons, there are not enough donors, not enough brains. I want to change that. I'm a first-degree family member of 2 sons who lost their life to psychotic brain illness, and I pledged to donate my brain to Harvard Brain Tissue Resource Center. Brain donation opens the door to hope and healing. Through advancements in brain science, the treatment of psychotic bipolar illness will improve. I believe in a future where other families will not endure the fierce loss we have. And I want to be a part of that future. Today, I will talk to the director of the Brain Tissue Resource Center, Dr. Sabina Berretta. She so generously agreed to tell us about her research and how it will change the treatment of major mental illnesses and other brain illness. Let's learn more. So, we're here today with Dr. Sabina Berretta, and I want to thank you for allowing this interview.
My pleasure.
And your generous tour. And so you're the director of the Harvard Brain Tissue Resource Center.
Yep.
And so can you please tell me how you got in this field and how you made it from Italy to here?
So I studied medicine in Italy at the University of Catania, but with the idea since the beginning of doing research in neuroscience and particularly in clinical neuroscience. It took me a while to get there, so after I graduated from I worked in a neuroscience lab throughout medical school, but then once I graduated, I was lucky to receive a scholarship from the CNR, the Italian NIH equivalent, if you will, to come and work in the States. I worked at MIT with Dr. Greville for several years as a postdoc, and that sort of got me closer to what I wanted to do, which was basic research applied to brain disorders. Eventually, I wanted to work on the human brain. All approaches to studying brain disorders are very, very valuable. So we need them all, from genetics to animal models to clinical work to imaging. Working on the human brain gives us one piece of the puzzle, but one that I was particularly interested in, which is what are the changes in the brain that give rise to symptoms in brain disorders. And I was particularly interested in symptoms related to emotion regulation, so depression, anxiety, mania, psychosis.
Right.
So I joined Harvard Medical School and came here at McLean Hospital because there was a brain bank, the Harvard Brain Tissue Resource Center, that could give me access to human brains. Obviously, our brain bank, which is part of the NIH Neurobiobank, distributes tissue to investigators across the world, but I wanted to work with Dr. Benes, who was at that time one of the most prominent investigators on schizophrenia and bipolar disorders working on human brain. So I moved here a long time ago in 1997 and eventually set up my own lab. So that's sort of my brief history.
Well, thank you for sharing that with us. So what is the most exciting research that you feel is conducted here that you're most excited about?
Well, this is actually really, this past 1 or 2 decades have been one of the most exciting times for neuroscience research. And this is due in great part to several technical developments or methods that have been set up, but many of these here in Boston, that allowed us to detect changes at the cell level in a detail that we could have only dreamed before. So methods that allow for single cell analysis like transcriptomics, proteomics, spatial transcriptomics really allow us excuse me, not only to look at changes in protein and gene expression at the cell level, but also to try to understand how different type of cells in the brain, in each brain region, work together. And this is really essential to understanding brain disorders, because before we could do that, we were focusing on one cell type or another, whether it was projection neurons or medium spiny neurons in the caudate or particular types of interneurons. But it was difficult to look at how they coordinate their functions in a way that may eventually be disrupted in brain disorders, causing different symptoms. So this is, in my view, one of the most exciting development in our field, and one that is bringing us much, much faster to understanding more about how brain disorders, particularly psychiatric disorders in which there is no overt neurodegeneration. So there is no cell death, but there are very important molecular and cellular changes that are very difficult to study if you don't have the tools that we have now. And these also allow us to link a lot better with, on one end, with genetics. So one of the biggest challenges in understanding brain disorder is you may have found what are the genes that are either causative or at least risk for a disorder, but how do you understand what changes do they cause? But now that you can do it at such a depth and with big data as we can generate, we are actually getting much closer to understanding that. The other side of the challenge is now we found changes in the brain at the level of single cell and how these different cells cooperate with each other, but how do they cause symptoms? So that's the next challenge that we are, and again, methods that have been developed in the last 10 years, including machine learning and natural language processing, are helping us to sort of join these different aspects of these disorders and hopefully go from genetic to biology to clinical back to genetic until we sort of understand better these disorders. Psychiatric disorders, the reason I'm highlighting them is because there is a lot of misunderstanding of these disorders. Because there is no overt neurodegeneration, there is this misunderstanding in our culture that because there are no brain changes, they are not really disorders, not like Parkinson or Alzheimer. Or in reality, there are obvious changes, and nothing that we do changes if our brain doesn't change. It's just that they are at a different level of resolution. So we need to dig a lot deeper, and we need better tools. But again, we have them, and they are developing much faster now. They are leading to a much stronger interest in studying the human brain, even after that. And the reason I say this is because there used to be a lot of concerns with studying the human brain after that, thinking that it would be too difficult to really understand what are the changes that cause symptoms, particularly, after a long history, after a long illness that, may have evolved over time. Now, with the new tools, the new technology, this has become a lot easier to understand, to do, and therefore there is a renewed interest in working with human brain after that, which is leading to, again, more and more important discoveries.
So what I think I heard you say is that it's the omics, technology with all the diversity of looking at the different parts of brain function systemically on the cellular level, genetic, RNA, DNA, structurally, and able to look at that data, perhaps using AI techniques to analyze this data. Right. And that's bringing you hope. It's bringing me hope too. Where do you see it going? I mean, do you think this is allowing a rapid advancement in the understanding of brain disorders, or how do you frame that in the big picture?
I do think so. Obviously, brain disorders and the brain are incredibly complex. So, there are changes that are happening rapidly. Our knowledge is increasing quite fast, and we're beginning to understand a lot better what we need to look at, and therefore what could be targets for therapy. And on the other side, therapeutic approaches are evolving just as fast, which again allows us to have hope that we can eventually have better approaches to a lot of these disorders. Monogenic disorders such as Huntington still are not quite there. We obviously don't have a cure or even a way to slow down the disorder, but I take that as an example because we are beginning to understand what needs to be done. And this is very recent findings that shifted the approach to therapeutic strategies very, very significantly. But that also gives us hope that this can also happen for multigenic disorders, such as most of the psychiatric disorders.
So it's the convergence of the science with the therapeutic approach coming together that you see moving things forward in a very positive, more rapid way than we had thought before.
Yes.
It is exciting.
And that also highlights why considering a brain donation is such an essential gift that we can give to society. And it is important that we understand that we all can help with that, that every brain is precious, every brain contains a wealth of information that can inform these studies, whether it is from people that weren't affected by brain disorders or people that were affected by brain disorders. They all tell us a story, and the more this work evolves, the more it becomes exciting, the more we need to collect brain donations. So one important thing to emphasize, and possibly the take-home message of what I'm saying, is the work that I was describing in psychiatric disorders, in neurodegenerative disorders, in rare genetic disorders. The advances that we are making would not have been possible if it weren't for the generosity of so many brain donors and their families that allowed this to happen. We would not know what to do and how to approach these disorders if it weren't for people that had the foresight and the generosity to consider a brain donation.
Right, so we've shared that I've pledged to donate my brain in honor of my 2 sons who died from psychotic bipolar disorder, and I just feel grateful to be a part of helping things in any small way that I am, and encourage everybody to please consider that. It's so important.
And that is very generous of you. It's not an easy choice. It's not an easy choice for who is planning to become a brain donor, but also for the family. One of the most difficult things is that the family needs to call us immediately after a loved one passes, or just before that. That's an incredibly difficult, painful time, and it is really humbling to see how important it is to so many families to go ahead and do it, despite the challenges, despite the pain that they're going through.
Right. Yes, I've prepared my family. They all know that this is my desire.
And that's actually a very good...
And we've talked about it, so I'm hoping that helps facilitate the process many years from now, God willing, when I die.
Okay.
Yeah.
Yes, absolutely. So discussing this with families, whether registering or not as a brain donor, registration is not a consent, but it's actually a way to discuss brain donation with the family and letting them know. And many times families contacted us. They may have had some concerns, they may not have, that may not have been their wish, but they knew it was their loved ones, and they go through because they know that.
Yes. Well, thank you again for your incredible generosity and the work that you're doing. It's so important, valuable for individuals, society, humanity. Thank you.
Well, thank you. Thank you.